Question is asking us to calculate the wavelength of a radiation, and it's given us frequency 1.5 times 10 to the 13 hertz. All right, so we'll use our equation C equals lambda nu, where C is the speed of light, lambda is the wavelength, and nu is the frequency. Let's rearrange this to solve for wavelength. So we'll divide through by frequency and get C over speed of light over frequency. We'll plug in the numbers we're given. The speed of light will give you on your reference sheet 2.998 times 10 to the 8 meters per second. Nu, which is frequency, is given to us 1.50 times 10 to the 13. Hertz is per second. The seconds cancel out because they're both in the denominator of their own fraction. And we're left with meters. That's a logic check because meters is the SI unit for length. We're on the right track. Let's punch these numbers in our calculator. 2.998 times 10 to the 8 divided by 1.50, you can add if you want, times 10 to the 13. And we're looking for a very small number because well, not all wavelengths are small, but this one, yeah. So anyway, it turns out it is a small number. All right, we need to trim that to 3 sig figs because the measurement we're given in frequency has 3 significant figures. So our answer is 2.00 times 10 to the negative 5 meters. Second part, so there's our answer. All right, so the second part of this question is, does this radiation have a longer or shorter wavelength than red light? So let's compare this to red light. I just copied this from the Google image. So red light typically has depending on the shade, has a wavelength about 700 nanometers. That's a good thing to remember. You'll memorize these because we use them so frequently. Right, and if you want to convert this to nanometers, let's do that. Or you can convert nanometers into meters. So either way, we'll have to compare apples to apples because our answer is in terms of meters. All right, so let's just do that. So the answer we had 2.00 times 10 to the negative 5 meters. We'll use a conversion factor, which is also in your reference sheet between nanometers and meters. All right, so we need to set up a conversion factor to get rid of meters and end up with nanometers. 1 nanometer is 10 to the negative 9 meters. And that's going to give us the same number, 2.00. Right, so everything is the same. So negative 5 plus 9 is negative, wait, what did I just say? Negative 5 minus a negative 9 is plus 9, so that's going to be 4. All right, nanometers. So about 20,000 nanometers. Well, 20,000 is way over here. So we're looking at the probably the infrared or maybe even the microwave range. Probably in any case, our answer is much longer, right, than the wavelength of red light. Longer wavelength than red light. So there's your answer to the second part. That's a lambda, by the way. All right, make sure that's the question